Hello, my name is Amaryllis Garcia. I am part of Group A, Events that Shape the Nuclear Industry. I will be presenting Phase 3. I was assigned to research and analyze Chernobyl safety failures and impact and the industry impact. I researched how the Chernobyl reactor design, operating practices, and errors affected plant safety, how the Chernobyl explosion affected the environment surrounding it, and how the nuclear industry responded to this event. During the time that the Chernobyl reactors were in full operation, the Soviet Union had dominance in Eastern Europe. According to Mikhail Malko's report, the Chernobyl reactor design features and reasons for the accident, found in the recent research activities about the Chernobyl nuclear power plant accident in Belarus, Ukraine, and Russia. The RBMK design was developed by the same organizations and specialists that were involved in the development of the Soviet nuclear weapon. Therefore, the same level of secrecy was brought in the development of nuclear power reactors for electricity generation. Even a chief engineer of the RBMK reactor had a misconception on how a certain process worked. Accidents that had occurred in the past were kept classified, and that information was only available to top officials. The Soviet Union had this mindset to stay on top and prosperous, risking their operators' safety by keeping them uninformed. Even the regulations set in place were not safe. The Soviet Union ran their plants with an extreme lack of safety culture. The RBMK reactors had major design flaws. One of the flaws, which greatly contributed to the explosion, is a positive void coefficient of reactivity. This coefficient usually only minimally contributes to the overall power coefficient of reactivity in a reactor with the same type of moderator and coolant. In the RBMK reactor design, the coolant and moderator are of different materials, water and graphite respectively. When there is an excess of steam production, the cooling to the reactor is reduced, but since the moderator is not affected by this and continues the nuclear chain reaction. Since there is a reduction of neutron absorption by the coolant when it turns into steam, there is now an excess of neutrons which are free to enhance the nuclear chain reaction. This in turn allows for an increase in the overall power coefficient of reactivity. Another design feature which in turn affects the void coefficient is the operating reactivity margin. This is the effective number of rods in the core. The operators believed that they had enough to sustain the core if necessary, but they misjudged their predicament. They also were unaware of the initial positive reactivity that could be added when they scrammed the rods. This was also due to the rod design. The rods had graphite displacers at the ends that were 4.5 meters long. The reactor was 7 meters long, so this allowed water columns to build above and below the graphite displacers when the rods were withdrawn. When the rods were inserted from the top of the core, they would displace the water columns form, absorbing less neutrons than the water when inserted. This would then cause a positive reactivity surge due to more neutrons free to continue the nuclear chain reaction of reactivity. A number of operating errors also contributed to the accident. The staff was delayed in their turbine testing due to an order by the lead dispatcher to keep Chernobyl Unit 4 reactor online at full operation. This in turn kept the current shift from performing the tests and was turned over to a shift that had not planned the tests. As the reactor was being brought down to the required power level for the test, the reactor continued to decrease in power without operator action. The reactor operator, the shift engineer, and the shift foreman planned to continue inserting the absorbing rods to shut down the reactor. They were forced by the deputy chief to withdraw the rods to bring the power level back up to what was required per the testing. Had the crew considered taking into account safety of the reactor operations, they may have avoided the actions leading to the explosion. The subsequent explosion of Chernobyl Unit 4 reactor released between 13 to 30% of uranium dioxide fission products into the atmosphere. About 60% of this released into Belarus, with the remaining amount spreading into the Russian Federation and parts of Ukraine. 28 out of 600 workers died within weeks of the accident, and hundreds of thousands received radiation exposure between 1 to 200 rem during the cleanup. The general population evacuated only received about 0.1 rem per year, which is comparable to natural background radiation. The only major effect linked to radiation exposure was thyroid cancer found in children. This was due to the intake of milk, which contained the radioactive iodine. 6,000 cases have been reported to date with 99% recovery. The psychological effect has been the most detrimental to the health of the population, as it has been with other nuclear accidents. The government of Belarus continues to evaluate land safe for repopulating, but the people will forever remain scarred. The U.S. Nuclear Regulatory Commission conducted a few assessments to evaluate if any changes were needed to be implemented across U.S. reactors. The Nuclear Regulatory Commission concluded that U.S. reactors were safe from a potential accident like Chernobyl due to safer plant designs and capabilities to shut down reactors and contain radioactive release efficiently. The Chernobyl aftermath does provide continuing lessons on how to decontaminate structures and re-inhabit evacuated areas post-nuclear accident with fission products released. The Nuclear Regulatory Commission will continue to examine the progress made by the affected countries in these matters. There were major changes that were implemented into the design of the RBMK reactor. One major change was in the reduction of the effect of the positive void coefficient of reactivity. This was modified by increasing the number of absorbers in the core, increasing the minimum operating reactivity margin required during reactor normal operations, and increasing the fuel enrichment. Another major modification was in the control rods to prevent the surge of positive reactivity caused when they were inserted. This was done by retrofitting the control rods so that, when fully withdrawn, the columns of water would no longer form under them. Since the Chernobyl accident, over 1,000 Soviet Union nuclear engineers have visited Western nuclear power plants. There has been cooperation between Eastern and Western nuclear power plant operators with the formation of the World Association of Nuclear Operators in 1989, linking operators from over 30 countries. The International Atomic Energy Agency has also been a great asset in the safety review of projects by the Soviet Union, which has brought collaboration amongst Western and Eastern engineers. According to the World Nuclear Association, since the accident, all Soviet reactors have been improved vastly. This is mostly due to the development of a nuclear safety culture, which has been encouraged by East and West collaboration and the investment in improving the reactors. The Chernobyl accident has brought about a shared initiative to continue to improve and practice safety in the nuclear industry throughout the world.